Okay, now we move to region of convergence, ROC. ROC of Z transform is the region in complex Z plane where some of Z converge or exist or absolutely summable. For example, we need to find the Z transform and the corresponding ROC for H1n, which is equal to A with the power of n multiplied with un for n larger than 0. For example, this is the Z transform of H1. This symbol means the direct transform of Z. A divided by Z multiply with the power of n. Okay, you can refer to the previous example how to get this equation. Since it's for n larger than 0, meaning that it's a right-sided sequence, so we assume that it's causal. Based on this function, the closed-loop expression A with the power of n, so we have this function 1 over 1 minus this function A over Z. From this one, this function A over Z must be less than 1. If we rearrange this equation, we take Z to the right side, meaning that Z must be larger than A. Okay, Z must be larger than A. So this one can be transformed into the ROC. Okay, so observe that the Z transform of H1 only exists for Z larger than A. If Z less than A, the Z transform of H1 will diverge. Therefore, the ROC of H1, okay, is the shaded region around of poles radius A. Okay, this is A along this Z complex plane. Okay, so the shaded area of ROC for Z transform of H1 is Z larger than A. So we shaded this area with these lines. So this shaded area is Z larger than A. So for Z less than A, we leave this part with a plain area. So the Z transform of H1 is equal to, when we simplify the previous equation, 1 over 1 minus A over Z. So we have Z divided by Z minus A, where Z is larger than A for the ROC. This is where Z is larger than A. In this circle is Z less than A, where A is the radius of the pole.